Well, I just want to have an overview of the field. The field is gigantic, and it's really impossible to, in 45 minutes or however much I run over, and we can run over, fortunately, a little bit because of our video problem, but we have the room into the evening, and for all of you diehards, cold fusion diehards who want to stay and listen. But we really should establish some principles here to begin the day. And I think these are the two concepts that we really have to get in mind, which seems to have been overlooked by the dominant scientific culture. And that is, you cannot use theory to reject experimental evidence, no matter how strong the belief in that theory. That is at the root of what is wrong with the perception by the establishment of cold fusion. They have theories that suggest that this cannot happen. And this blinds them, they have paradigm paralysis, one might say, to the possibility that there are other things going on there that they don't understand, that we collectively don't understand. And I find this actually rather remarkable because we have today, as you all know, large mysteries that are widely touted in the media, such as the fact that the age of the universe appears now to be shorter than the age of the oldest stars. Kind of a problem, I would say. And they admit, finally, even the New York Times admits it. It actually seems to me, and I will make a prediction today, I think I will be proved correct. I don't know exactly in what form I will be proved correct, but I suspect that the missing mass problem of the universe, which is behind that issue of the age of the stars and the age of the universe problem, will be explained in part due to what comes out of the cold fusion field. I can't prove that, of course, but I believe the joke will be on the physics establishment, and they will rush with open arms to us once they realize that our little piece of experimental work fits their problem to a T. Another myth is that extraordinary claims require extraordinary proof. That's not true, despite Carl Sagan's aphorism. And I like Carl a lot. I think he's gone astray a little recently on the matter of cold fusion. He was positive or open-minded for a while, and recently he made a speech saying it would not have any value. But we don't need extraordinary proof. We just need proof. And we have proof, okay? Any mechanical engineer who can measure temperature, who can measure use dynamometers to measure mechanical power going into a rotary device, people who know how to measure tritium because it's used as biological tracers and so forth, the evidence is overwhelming. Now, for some of you new here, it might not be overwhelming, and please understand where I'm coming from. I'm not here to tell you and give you a tutorial, necessarily, of why you should believe in cold fusion. That's not my job. I do believe that we have a major scientific discovery and a major technical revolution going on. It's your business, for those of you who may be neutral to highly skeptical, to read the evidence, and it's in our flyers and so forth, and other companies that have got their information here, to look into it. But we will present an awful lot of material today that I hope will lead to persuading you if you are on the line. The main focus of the day will be scientific findings, technological developments, and commercialization. All these things are, by the way, proceeding in parallel now. There are those who are much more interested in the science, and that's fine. We need those people to work in a dedicated way in the laboratory to reveal the mechanism of this fantastic mystery that we have. But in a parallel way, much as Ira Magaziner predicted at the first congressional hearings on cold fusion in '89, he said we've got to go in parallel with technological development. And he was absolutely right. Now it's definitely true, because we will have, I predict, technological developments, home heating units, electric power generators, what have you, probably before we understand fully what's behind the science. Of course, commercialization is going on too, because there are many here, such as Eneco and hydrodynamics and clean energy technologies from Dallas, who so graciously came up, and Polytech Corporation. These people are hard at work to produce products, get patent positions, and so forth, in parallel with the actual experiments and what have you. There are other issues, however, and I do not mean to gloss over these. I just want to make a kind of a demarcation between what we're going to talk about during the day and what we will talk about this evening for those diehards who after supper perhaps will come back. We have permission to go from about 7 to 8:30 in this room and have like a panel discussion concerning these issues, which are government policy toward coal fusion, congressional and executive actions that should have been taken or may still be taken in the future, research funding at national laboratories and universities, national security, a very big issue, not only from the possible military applications of this technology, definite in my view, but also the very serious matter of our economic security, vis-a-vis intense efforts now underway in Japan with an infrastructure far more open to this technology than in the United States. As to military, by the way, the field is producing regular, low-level, but significant amounts of tritium. I need not remind an audience like this that tritium is an ingredient in thermonuclear weapons. And it's also being produced currently by a very inefficient and absurd way, namely a breeder reactor type approach at Savannah River, which I don't know whether is open or not, but they plan to spend billions of dollars to reinitiate our tritium production for nuclear weapons, because tritium, you know, has a 12.5-year half-life, and we have to keep restoring it. Of course, we don't need that many nuclear weapons anymore, thankfully, but nonetheless, we have to worry about the Gaddafis and the Ayatollahs of this world knowing how to make, and they do know how to make tritium now because it's in the open literature of cold fusion, and it's not classified. The economic impact we've talked about, gigantic potential geopolitical consequences, the environmental impact, which thankfully will be extremely beneficial. This is the best discovery for the environment, in my view, ever. Social issues, which will have come from all of that. Taxation, we now tax gasoline. Who's going to pay for the roads when we have free energy and we don't have to pump gasoline, or nearly free energy? I shouldn't say free energy. Science education. Right now in the United States, cold fusion obviously isn't being taught. Okay? It doesn't exist in virtually all physics classes, chemistry classes. There's going to be a huge lag. We have an outstanding counterexample to that today, in a way, of Ray Conley from MIT, who is doing experiments in the Department of Astronautics, and he has some excellent results to report later. Also, the process of science is something we could talk about this evening. What do we know about the process, or what have we learned about the process of science as a result of all of this hubbub that has occurred since 1989? Media coverage of scientific controversies, an outstanding example of which we had yesterday, and which I was happy about, by the way, even with all the negative aspects apart, and research ethics in reporting scientific results, and the general decorum of science, you know, being polite to one another within reason. You know, it's funny, the cold fusion people are often accused of being rabidly pro and using all sorts of vituperative language against the opponents, and yes, we have been provoked to that extent, but I dare say if you go back in the record, you will see, and just it's on the historical record, you will see who fired the first shots and who continue to fire the shots. If you listen to the NPR tape of yesterday, you will find Dr. Goodstein, for example, of Caltech, suggesting that Mallove and others are not being polite enough. Whereas in the very time that we were there, he said the science is lousy, it's not being done right, all sorts of negative stuff. We'll get the quotes out and, you know, pretty much QED prove who fires the shots. Okay, but let's get off that topic and let's just get on to the organization of the day. Dr. Peter Greneau will be talking about very unusual anomalous forces in water plasma discharges, which show that physics does not know everything. The clean energy technology people from Dallas, Texas, will be talking. Now, we are minus 2 videotapes for various reasons. These tapes from the clean energy technology people will be available, they expect, in a number of weeks. There are some developments occurring in that field. We might put the coffee break here, and Jim Griggs will come afterwards, since we really do want to show the videotape of the hydrosonic pump. It is a most remarkable instrument. And then in the afternoon, Ray Connolly, Fred Yeager of Eneco to talk about business and patents. And I'll say just a word about the eQuest. They're deeply involved with experiments now. They're also a little cash short, I think, for flights and so forth, and therefore they couldn't make it. We tried our best to get demos here. You know, it's real tough. You have to bear with us. These things are working now, there's no doubt about it, but as to our ability to get them here, that remains to be seen. And that will remain for another year. I know we'll have them next year because we'll be far better along at that point. Just as an example, it would have been possible for Dr. Dennis Cravens to come and put a little unit on this table with a ceramic proton conductor device that has a circulating water heat transfer loop, and it does produce twice as much energy out as input. And you can put your own meters on it to verify it. He specifically built it so he could show and demonstrate totally reproducible double heat output at about the 5-watt level. That's a nice little demonstration unit. It should be in every physics lab in the country, and maybe it will be soon enough. And then at the end, after we have Professor Hagelstein with theory and Professor Keith Johnson talking about his theory and his very unusual activity in producing the cold fusion movie, we'll hopefully have Dr. Noninsky from Fitchburg State College here talking about his work, and then some amazing new areas that Bert Wergefeld of Polytech USA from Hawaii will talk about. Well, I guess I've shown this slide for a number of years now, but it remains the same. Yes, it's real. Whatever it is, it's real. And let's define it first, because it isn't just deuterium-deuterium fusion, obviously. It's an unknown phenomenon that gives rise to excess power and nuclear effects in metals in contact with liquids and that are in contact with liquid and gas media that contain hydrogen and its isotopes. That's a generic definition of cold fusion. There are many systems now, not just the original Pons-Fleischmann. There have been substantial excess powers confirmed in a range of systems, and it's orders of magnitude beyond chemical explanation. That answer keeps coming up in experiment after experiment after experiment. There really is no reasonable doubt about this in my view. And it is also beyond any known mechanism to store that energy. It just can't be stored. If it could be stored, Duracell should be interested in it for that alone, but they're not. It's not stored, so Duracell, don't call Mallove. Nuclear products are confirmed. I think we know how to measure tritium. I think dozens of laboratories know how to measure tritium. That miracle alone, quote, miracle, is enough, should be enough to make the physicists sit up and take notice, but of course they haven't. That has been confirmed. Helium-4 has been confirmed, charged particles, and low-level neutrons. Fortunately, low-level. No commonly accepted physical explanation exists. Does that mean it doesn't exist? Yes, to the establishment, that's what it means. You cannot explain it, therefore it doesn't exist. This is the complete inversion of science. Overwhelming rejection, of course, and an immense scientific and technological revolution is in progress now, and it is accelerating very rapidly. Why should we be interested in this at all? Well, because right now most of the planet is covered with the combustion products of that noxious black substance we call oil. And there are giant oceans of water that might be fuel. Burn water. What better idea can you come up with? That's great, so we can eliminate getting black goop from there, okay? Hot fusion people have been trying to do this for a long time, to use the deuterium in water to run hot fusion reactions. But now we have a method that does it in the cold and on the cheap. We don't have to wait 50 years for it. We can have it now. That water is our fuel, okay? Only a cubic mile of it will be needed for a long time, if cold fusion is, even if cold fusion were just the standard deuterium-deuterium fusion. I also want to point out that there's another ocean in this picture. Does anyone know what it is? Where's the other ocean? What? Ocean of air, yeah, but there's another one even bigger. The vacuum of space. It is no secret that the idea of zero-point energy has crept into the cold fusion debate. The possibility that the vast space between the stars and through our bodies, which is, we know from classical physics, is filled with vacuum fluctuations at a density of something on the order of, and Peter, correct me, 10 to the 93rd grams per cubic centimeter. That's what some cosmologists say is there. The only problem is we can't tap it. Or can we? Is cold fusion partaking of that vast energy ocean? Well, some of you may be inclined to say that can't be. But I just want to refer you to one paper, Physical Review E, August 93, by Dr. Daniel Cole of IBM Corporation in Vermont, and Harold Putoff of the Institute for Advanced Study in Austin, Texas, extracting energy and heat from the vacuum. They have theoretically proved, and to the peer review standards of Physical Review E, that it is possible to extract vacuum energy. Whether this is technologically possible and whether it is happening in any cold fusion experiments today remains to be seen. For a long time, I was a full believer in the nuclear explanation. It may still be valid in many cases, but I'm increasingly tending in that direction, for what it's worth. That's just my opinion. All right, the story began on March 23rd, 1989, when our two heroes, now in France under very great Japanese support, the Toyota Motor Corporation, a subsidiary, they're working in a 50,000 square foot lab, they announced cold fusion. For those of you who have been on Mars for the last 6 years almost, they had a little cell, they had palladium cathode, platinum anode, and they had heavy water in it, and it was heavy water here, and it was in a bath, and they ran a current between the cathode and the anode, and they said, we get more heat out of this in this little calorimeter where you measure that temperature and you measure that temperature and you get a delta T and you figure out the difference between it operating with its magic, cold fusion, whatever that is, and with some kind of a control experiment. They were producing excess heat. They have never backed off that claim, ever. They did have claims of neutrons in the beginning, which they did back off. They said they were getting 30,000 per second, I believe. They were not. And they had the courage to admit that they were wrong when they found out that they were wrong. Thankfully, they were wrong. We don't need 30,000 neutrons per second coming out of the cell, all right, or whatever it was, per square centimeter. They also said they had tritium, and their tritium measurements weren't very good at the time, but lo and behold, others have found tritium. You know, if these two gentlemen do not win the Nobel Prize someday, you know, before they become a quantum fluctuation of their own, I would say the Nobel Prize has a serious problem. I remind you that the superconductivity award was only 1 year after the discovery of high-temperature superconductivity. Now, cold fusion is much more than just the Pons-Fleischmann process. It is about 9 or even more processes. The original one, of course. Then the molten salt process, which was discovered in Hawaii by Liebert and Liao. Not very much done today, but very interesting because it's high temperature and thermodynamically interesting. Then the Randall-Mills light water process with nickel and potassium carbonate emerged in '91, just at the time that I finished my book, Fire from Ice. Not time enough to include it in there, but the next edition, which I'm working on at the moment, which will have a different title, by the way, will have that and everything else in here. Glow discharge, low voltage discharge in hydrogen or deuterium gas. Ultrasonic activation. Many of you have seen on the back page of Cold Fusion Net Notes that there is an ad for a device that you can buy today in a laboratory and demonstrate that you can melt palladium underwater and generate massive amounts of helium-4, sort of commensurate with the excess heat. They're also getting transmutations, by the way, which they have not announced, but it's an open secret that they've got them. Massive amounts of transmuted materials on the surface of the palladium. Ceramic proton conductors, which are, you might say, the solid-state version of cold fusion, no liquids involved, and these are running very hot now in Hokkaido. Professor Mizuno there, Biberian in France and California, and even Dennis Craven's in the United States. Then this Italian process, which was announced last year in February or January, Piantelli, Focardi, Habel, who have a hot nickel rod that just keeps going and going and going and producing many watts of excess. In one case, it ran away and produced, near melting conditions on the surface, and they had to find a way to turn it off. Then magnetic and RF stimulation, which Cravens and Letts and others have found. And then last but definitely not least, turbulent activation, which may be related, I think it quite likely is related to the ultrasonic activation, but in ordinary light water, as you will see with the hydrosonic pump when Jim Griggs gives his talk, massive power. In fact, some of the highest power levels ever recorded in this weird cold fusion field. Indeed, as my son Ethan did in this cartoon of the iceberg, I mean, the metaphor is just perfect. It wasn't his idea. I told him, hey, Ethan, we got to have an iceberg. Unfortunately, he should have put a coal-fired or an oil-fired ship there. He put sails. He's get the wrong century, I think. But hey, Pons, look what's ahead. And what they're seeing is this little cell, cold fusion cell, the palladium heavy water one. But there was so much more, so terribly much more. They just saw the tip of a vast new physics. I'm absolutely convinced of that. Time will only tell. In fact, I think this iceberg is getting bigger and bigger and bigger, and it will, as I said before, perhaps encompass the entire universe. That is, maybe we'll give the cosmologists and the physicists a clue to the problem with the age of the universe and the age of the stars. Pons and Fleischmann did not stop, as this Sidney Harris cartoon would suggest, just because they were on the verge of where chemistry leaves off and physics begins. They didn't drop the whole thing. No, the cold fusion people, Pons and Fleischmann, despite enormous pressures against them, enormous vituperation and political absurdities that have occurred, they did not give up, they have not retracted, nor have any of the people in the cold fusion field that I know of, with the exception of one of the early so-called pioneers, Steve Jones, whom historically now, I believe, unfortunately for Steve, he will be regarded as a very tragic spoiler in the whole affair. It's sad for Steve, but this particular historical occurrence has created many bizarre situations, indeed. I would liken the Pons-Fleischmann situation to the discovery of flight. It's no secret that the Wright brothers flew on December 17th, 1917. And for many years afterwards, was it September? 1903. Thank you. I only get about 3.5 hours of sleep, guys, these days. You gotta give me some slack. Okay, cut me some slack. My family can attest to that. My daughter says I hide in my little cave, and I do. Okay, there's a lot of work to do. The patent office, of course, said at the time everything that has been invented has already been invented, And the physicists of that era, shortly before 1895, they thought they knew just about everything. Then good old Röntgen came out and showed that you could see right through your hand with X-rays. When they first heard about that, they thought it was a hoax. But for 5 years, this was not believed. They were flying in broad daylight in Ohio, on the Huffman Prairie. Reporters saw them. The Army said, prove it on paper to us. They didn't come out to observe it. They tried to sell the patent rights to the U.S. government for 25,000 bucks, and they couldn't interest the the Army, the War Department at the time, and it was just an amazing story. If you read Fred Kelly's book on their biography, you will see very similar situations going on. We of course know what happened with aviation. It exploded. It led to space travel ultimately and transatlantic flights. By the way, when one of the worst skeptics at the time, who said it could never be done, he proved mathematically that it could never be done. He was a great astronomer. Upon hearing that they had flown, and he had to accept it then, they did it in Fort Myers, Virginia, he said, well, they'll never have a passenger. How wrong he was. Here's another guy who did something small, like Pons and Fleischmann, like the Wright brothers. And by the way, they weren't in the field. There was no field, okay? There was no cold fusion field before Pons and Fleischmann. There was no really aviation field before the original aeronautical underground and the Wright brothers. And there certainly was no space travel field, except for science fiction people and so forth, until Robert Goddard and Tsiolkovsky and Oberth. And Goddard, not too many miles from here, launched in, I believe it was in March of 1926, his little liquid fuel rocket, which led to the whole space age. And at the time, he was called the Moon Man, and was much ridiculed for not understanding physics. New York Times ran an editorial saying he didn't have a high school physics education, but of course he was right. The fact you did not need anything to push against. All right, let's set the context. We are in a serious energy problem here. I've shared some of this with Fred Yeager of Eneco, who's interested in knowing where order of magnitudes are and what's happening. I mean, here's the integrated fossil fuel reserves of the planet projected into the future. It's going to end. There's no doubt about it. In fact, it's going to end our ability to use oil as our population soars to perhaps the 10 billion level, with only an assumption of final rate of consumption of 2/3 of the US rate. We have a huge deficit. We need some other energy sources. And we need them quick, because it's starting to diverge right here. There are energy shortages already. That's why we're having wars and problems, terrible things. I mean, this problem with the seceding Russian province has something to do with energy, to say the least. Okay, I imagine if they were sitting on sand instead of oil, there would be a less of a problem. And of course, if it goes to 15 billion, we have a real problem. Well, the hot fusion people have been trying to solve this problem of using water fuel for a long time. They have giant lasers, or the tokamak system, which we have here at MIT and Princeton and General Atomics. It's a noble effort, always was. However, I would say in the last 4 or 5 years, it's increasingly less noble, in that I think the answer that these former colleagues of mine were striving for, it was on the table for them, but they rejected it for their own paradigm paralysis reasons. They rejected it violently, and I think their serious misfortune will be they won't have a program in the not-too-distant future. I think with the new administration in Congress, I think there are going to be some very big changes in hot fusion funding. But anyway, the controversy erupted, and the hot fusion people reacted negatively. There was much media coverage. On 3 days in 1989, May 8th, unheard of, a scientific device made the cover of a magazine. It also made Newsweek. I don't think I have Newsweek here. Business Week, Time, and Newsweek. And part of the reason it just went was this little party that they had here at MIT. They had a wake for cold fusion. That was kind of, it wasn't just because of that party, but in general, the theme within hot fusion and within the physics establishment was that cold fusion was dead, and they had proved that it couldn't be done. And so they held a wake for it on June 26, '89. And that just shows that what happened in the story, the complexity of it, is that they rushed to judgment. They did not proceed in a scientific way, continuing experiments as many positive people have, and therefore, of course, they didn't find the results. Unfortunately, those results are being used today to show that cold fusion doesn't exist. Well, I wrote a book on cold fusion. I'd like to think of it as the book, because it's the only book, at least until this point, that says, apart from Hal Fox's excellent book, one of the pioneers in cold fusion publishing is Hal Fox. Cold Fusion Impact, a great book with a tremendous bibliography. That's also highly positive, as is his newsletter. But I was the first to say that the evidence was overwhelmingly compelling, and I now don't say that anymore. I say it's 100% certain. There's just no doubt about it. But that has led to, because of the negativism, despite my book and Hal Fox's book and radio programs and TV programs, still there is this feeling of derision in the US, and not so in Japan, where it is very, very active. In fact, Julian Schwinger, in his talk, reprinted in the first issue of Cold Fusion magazine, which I have a copy of here. This magazine, which was published at Wayne Green Incorporated in New Hampshire, Peterborough. Schwinger's talk in there, basically, he said in Japan that it would be developed in Japan and not in the West. And he may well be right to some extent. I'd say the thing that will save the United States will be the entrepreneurial spirit in the United States, such as embodied by people in this room, people like Fred Yeager of Eneco, Mitch Swartz of Jet Technology, Hydrodynamics, Jim Griggs, many such people, on and on and on, who refuse to accept what is obviously the unacceptable, namely the thought that cold fusion is nonsense. There is increased media attention to it. August '93 was a major breakthrough when Jerry Bishop, who normally writes for the Wall Street Journal, did this wonderful article in Popular Science on cold fusion. And then an even bigger breakthrough, and a great day for MIT, I think, to kind of take some of the sting off its reputation as a bastion of skepticism, was Technology Review. I don't know if they were supposed to bring copies of their leftover copies of this issue, which is Dr. Storms's wonderful essay about the status of cold fusion. It's shown coming out of the trash can, okay, which I think was an apt description. I give a little credit to my own efforts for this appearance in a way, because in 1991 I had submitted an article which was first accepted and then surreptitiously removed from Technology Review. I'm delighted that Ed had got his in, but it was too bad that in '91, when I would have said roughly the same things, they felt that it was too heretical to publish at the time. Maybe they were right. There was a pretty bad eruption, by the way, after this occurred, even in 1994. You can imagine what would have happened in 1991. Let me just give a schematic of the cold fusion problem, if I may. It is a unified phenomenon in my view. Despite the fact that we have nuclear effects and we have heat effects, you really have to look at it in a unified way. But this is how various people look at this problem. Some say that there's nothing there, like Taubes and, all right, not Goodstein will give, he wrote an essay in the American Scholar magazine in which he gave some possibility that it was real, but not very much, okay? Just because his friend Franco Scaramuzzi of Italy, good friend of his, is getting some positive cold fusion results. Therefore, that's the good cold fusion, he says. Everything else is the bad cold fusion, which is kind of unbelievable philosophical confusion, I think. And Huizenga, who says this is all pathological and close and so forth. All right, let's move up from this nonsense, which is, of course, what that is, and get into the realm where people say, well, there are some interesting nuclear effects. Like Steve Jones was in that mode for a while. And he said, well, I see neutrons and maybe tritium, but I don't believe this heat stuff, you know. The heat is way out of order compared to the products. It just doesn't make sense. The heat doesn't make sense. It's probably a mistake. And then there were some people who just believed in the heat and not the nuclear products. And then there were some people who believed that they were both there, but that they were unrelated, which violates what I know of Occam's razor. Simplifying theories. Doesn't mean that they couldn't have been separate, but I just don't believe that it was a likely possibility. They're unified. It doesn't mean that the nuclear products explain the heat one-to-one. Let's get that straight. They're related, in my view. but they don't necessarily have to be commensurate nuclear products. In fact, they probably are not commensurate in general. That's the vast mystery of cold fusion. But as to their relationship, that is the thing that is causing the heat, also being involved in, which is a miracle in itself, the excess power, okay, also being related to nuclear products, come on, guys. I mean, it's just, it has to be almost. All right, it's possible that it isn't. Two things existing together that have nothing to do with one another. I just don't believe it. Anyway, we need proof of these assertions. We can't just pontificate about them like the physicists do who say that there's nothing there. Well, these are the explanations. This one, which we've talked about, some unknown chemical or mechanical phenomenon. Absolutely impossible if you believe the measurements. You cannot store that kind of chemical, ordinary chemical, or mechanical energy. It is like the idea of storing a stick of dynamite in water. It just doesn't work, in my view. Nuclear reactions, we would call this the mainline cold fusion dogma. There is a dogma, okay? It's funny how human cultures act. Even the cold fusion people have their hierarchies. There are the conservative, fuddy-duddy cold fusion people who say it must be a nuclear reaction. Can't be zero-point energy, can't be anything else, can't be shrinking hydrogen atoms, can't be Professor Johnson's theories of Jahn-Teller bonds. It must, dynamic Jahn-Teller bonds, it must be mainline nuclear. One-to-one, we will find the commensurate products. Peter Hagelstein, a great friend of mine, a wonderful man, he feels it that way. Neutron transfer reactions, you will hear his view. He thinks he's absolutely right, just like Randall Mills of Pennsylvania thinks his shrinking hydrogen atoms is right. One thing you learn in cold fusion is that every preeminent theorist is absolutely convinced that their theory is correct. That is one of the most amazing phenomena. Well, actually, it was an obvious phenomena, but it's true. Then we have this one here, something else even more wonderful, and that these are auxiliary. That's the horse I'm betting on now, in a little bit of combination with this. Okay, this is out and that's out. That's the playing field, in my view. Or it can be a combination of things. It would have been very presumptuous in the early days of the field of chemistry to say, oh, chemistry is burning carbon. That's chemistry. There's nothing else. Just burning carbon is chemistry. No polymers, no buckyballs or anything else. We discovered the whole iceberg of chemistry. It took a long time. The same thing will happen with cold fusion, I'm sure. What would it take to get rid of all this? The exceedingly improbable determination that systematic errors have been made by dozens of researchers in half a dozen or more measurement areas, in each of which diverse experimental techniques have been applied. In other words, many different experiments, many different ways of measuring in each type of experiment. When you get all this multiplicity, my friends, you're talking about a near certainty. That's the basic reason to believe it. In the early days, there was every reason not to believe it, which is why I didn't believe it, okay? I didn't believe it for sure. I mean, I felt it was worth pursuing, but I didn't believe it for sure. It took me a year, at least, to come to that conclusion, whereas the negative people would accuse me and my colleagues of saying that we became true believers on day one. That's not true. It was a very difficult path we followed. Now let me review some experimental evidence, just very briefly, because we're really pushing the time envelope, but I hope this will be helpful to you. Cold fusion is very often thought of as not repeatable. Well, here's an experiment that you can actually buy. I don't think they'll really demand $100K from you now, but that was when their ad. And the eQuest Sciences people in California can repeatably generate massive amounts of excess heat in the tens to hundreds of watts range, we believe. We would like to see more data from them. But one thing that appears to be nearly certain now, kind of reverse from the usual cold fusion, where you are certain about the heat, very certain about the heat, but less certain about nuclear products. In this case, they have got massive helium-4, 552 parts per million measured at tests done at Los Alamos National Laboratory and actually tested and analyzed at Rockwell International, okay, in California. Plus or minus 1 part per million, okay? That's 100 times atmospheric, and there was no entrance of the atmosphere to this experiment. The background argon cover gas was only 0.4 ppm, and they have 552 parts per million, plus or minus 1 part. EPRI spent $4,000 to have that data tested. And as far as I'm concerned, it's case closed. I know that Tom Passel thinks it is, of EPRI, and I do. And besides, they've gotten it over and over again at different levels, admittedly, but tens of ppm, and it's not with gamma radiation. So there's something very extraordinary happening there. The other thing they are getting is transmutations on the surface of the melted palladium. They have to be careful not to melt it. They melt it underwater very easily, under heavy water. Jim Griggs of hydrodynamics will be talking about his hydrosonic pump, which works every time. It either produces hot water or steam, and he never intended to be in the cold fusion field. He just fell into it because he saw the Popular Science cover story, called Jed Rothwell and myself in. We evaluated it in our own method. We felt that he had a solid experiment. Others have come in and made it even more solid. It seems, in my view, proved, and Jim will tell you why later, that that system produces excess power on the order of kilowatts. Kilowatts of excess heat. And I have every reason to believe, and I won't go into all those reasons, but there are a number of reasons beyond this that suggest that it can be made much, much better. Yeah, after all, he never tried to optimize it, so why should it be that good? Okay? He just lucked out. Wonderful man that he is in designing that system. He didn't just do it by pure luck, but I'm saying he didn't intend to have an over-unity machine. He just happened to fall into his lap. But he can sell these machines anyway for very many other reasons that are very, very important. Here's another guy who's got helium, Dr. Melvin Miles of China Lake, and 3 sets of experiments from 1991, 92 to 93, and he's done the probability that all the experiments came out with the helium, the slight helium that he had, matching up with the excess heat versus the cases where there was no helium, essentially no helium, and no excess heat. The probability of that match, that coming out by random chance, just a complete fluke and an experimental error, is 1 out of 134,217,730. Big odds, my friends. He's got helium-4, I think. He thinks so. Fritz Will, one of the most careful men I have ever met as far as an experimentalist. A man who put his entire reputation on the line when he left the GE Schenectady research labs to head the National Cold Fusion Institute. Yes, it closed down due to the politics and the lack of money and everything else. But at the last international conference, and now published in the Journal of Electroanalytical Chemistry in '93, is this conclusion that reproducible tritium can occur. That is enough, should be enough to make everyone take notice. A careful fellow like Fritz Will, precise man, impeccable ethics, impeccable standards. He's willing to put his name on it. And he makes probability statements, too, that it just cannot be a mistake. Okay? It just can't be, as far as he's concerned. But you can look at the paper yourself and see what he says. We have Tuggle and Clater at Los Alamos with reproducible tritium. Many types of tritium measurements have been done at Los Alamos. Our nuclear weapons facility generating tritium, and the director not taking note of this. Interesting politics. Fascinating. Then we have this incredible paper of Reifenschweiler, which didn't even occur during cold fusion. It occurred 30 years ago. But of course, he heard of cold fusion. He was at the Philips lab in Holland. And he found, to his astonishment, well, he knew at the time there was something weird going on, but he was too busy to publish it at the time, and probably no one would have allowed it anyway. But he found that temperature changes in a titanium powder inside a Geiger tube, which was being tested for Geiger tube applications. As the temperature went up, first of all, the counts out were steady as they should be. Temperature should not affect radioactivity, correct? gentlemen and ladies? Well, it did. It declined. And here he also measured very carefully the pressure of tritium to test whether, was it coming out, was it being gotten rid of, and could that explain the decline in the tritium counts in the Geiger counter? And the answer was no, because the tritium pressure was the same until it got very high, and then for some reason the counts went up again. Unbelievable phenomena occurring. That is in Physics Letters A, a very mainstream science publication. When this first came out, some of my colleagues said, well, every lab on the planet should be doing that experiment, that the heat, would change radioactivity. Well, I haven't heard any attempts at replicating it because, of course, they know it can't happen. That's why they're not trying to replicate it. But there are people who are pursuing it nonetheless, looking at the background of it and so forth. Here's a wonderful result from the proceedings of the Fourth International Conference, accidental, by Makubri at SRI International, where his cooling system got stopped up briefly, and then what happened was he got this tremendous 368 kilojoule heat burst. And it went up. Look at the temperature rise. And Makubri's calorimeter is so good that little fluctuations here are real, are measurable. This is like a redwood tree sticking out of the forest of the noise. I mean, there's just no way that this is not true. This is true. This did happen. And that suggests what Martin Fleischmann has said, that heat will be a sort of a positive control system coefficient to accelerate the reaction. Piantelli and company have this nickel system with just pure hydrogen gas, not even deuterium gas. And they get a very hot cathode. I think they have, I suspect they have some secret conditioning mechanisms for it, maybe even relating to magnetic fields. I don't know until they fully publish. Most recently, we hear from our inside contacts at the University of Siena, Piantelli has found 50 keV gamma rays off the nickel, and he is going to be publishing on that. He's putting a paper together. In essence, this is their curve. They have a calibration curve here, and then they trigger the process somehow, and what you see is coming down here, heater input power and the nickel temperature. There's for the same input power, I'm getting lost here. For the same input power, they achieve the same temperature. Now, for a different input power, they're able to achieve the same temperature, so that tells you the excess power. And the excess power is indefinitely, it just goes. This wattage just seems to go and go, and they went for 3 months and it didn't stop. And then we have the ceramic proton conductors of Mizuno, and above the calibration line, this is the input power, minute input of electricity, absolutely minute input, and the output is always above the line. This is the calibration line. And George Miley, a hot fusion scientist at the University of Illinois, does this. He talks about that in the proceedings of the Fourth International Conference, but also this wonderful, wonderful thing that has just happened. A select peer-reviewed set of papers from the proceedings of the Fourth International Conference is in Fusion Technology Supplement. And Miley put his own paper in there, and rightly so, because he's getting several kilowatts per cubic centimeter in a thin film approach using sandwich layers of various kinds. So he's got a little cold fusion reactor, and he continues to be a hot fusion person himself. And here we have something that may or may not be related to cold fusion, but I think it's fascinating. I suspect it is. May 8th, 1994, Business Week. What page is it? Page 47. There's some folks here who know more about it, but shall remain nameless. They have found this Gunnerman patent and process, which has now been tested in automobiles and trucks, and the Caterpillar Corporation is involved with this outfit in Reno, Nevada, of all places. They have a fuel called A55, which is 55% water and 45% gasoline and 45% diesel fuel, whichever way you want to do it. But it's mainly water, okay? It's 55%. And what they get is, when they test it out in automobiles and trucks and buses, they get 30 to 50%, and I heard one recent report, possibly as high as 100% more miles per gallon on the oil fraction. So in other words, we could cut our oil, if we used that A55 fuel right now, we would cut our oil imports dramatically. And I think that's what they intend to do, okay? Except I think they will be superseded by other better things. But nonetheless, it's a very good illustration that some strange things are happening with water. And here's the punchline on it. It doesn't work if they don't have nickel welded to the insides of the combustion chamber. Take the nickel away, and the effect goes away. Same thing with the light water process, eh? But one of the best results of all, in some sense, to help us know what the mechanism, you can't even know about, because this man is hiding them. His name is Kevin Wolf, Professor Kevin Wolf at Texas A&M University. And he is a physicist, and he became enwrapped in the cold fusion controversy from the very beginning. He discovered tritium and neutrons, wonderful guy. But because of the reigning terror, I would call it a terror at the time, where Gary Taubes alleged there was fraud going on at Texas A&M, he became terribly afraid. I don't blame the guy. They almost have immolated and hung John Bockris, his colleague. There's bad blood between these two. But this gentleman withdrew his tritium results, but he continued to do, in 1990, during the terror, the Taubes terror, he continued to do his work because there were certain factions within EPRI, we understand, that didn't like cold fusion, so they hired this guy to disprove cold fusion. They gave him a lot of money, about $300,000, which he hasn't spent. He hasn't spent it all. He spent about $60,000, $70,000, I understand. But he was doing cold fusion experiments, getting neutrons. One day, he looked at cathodes with a Geiger counter, and he found that they were hot, radioactive. And then he examined them with a gamma ray spectrometer, and he found dozens of lines, I understand, of gamma spectral signatures identifying the 7 transmuted isotopes, silver, ruthenium, and rhodium. He was going to put, for the benefit of the field, even though he doesn't believe it's cold fusion, he believes it's a weakly interacting massive particle, a WIMP from space, that happened to hit many of his cathodes in that one particular instance and created this unbelievable transmutation, okay, kind of like a cosmic ray event. He believes it's due to that. And he was all set to say this at the 4th International Conference on Cold Fusion. But the forces of evil prevailed and threatened him with dire consequences should he show up at Maui and actually give these results. I think that is tragic. Actual results, which he believes in fully, lots of people have seen. I haven't seen them, but I know all the different people who have seen them, and they have 100% credibility with me. This man has transmutations leading to understanding of the mechanism, but we cannot know the results, even though in effect we're paying for it by our tax to electric power companies for the EPRI, EPRI research funding. Well, we're ending here right now. I've gone on perhaps too long, 15 minutes too long. Ethan did another cartoon, SS oil age going down. See that? He's got an anachronism there. How can the oil age be going down in the sail age? He'll get better. He's into too many things. He's into music, and we have a wonderful family, actually, to survive this kind of a problem of cold fusion and other problems. But this is the oil age really going down. There she goes, guys. You've got to have this in color. This is Popular Science. And there are some of our friends, Taubes and Huizenga. They're playing with their musical instruments on the band, oblivious to the fact that there are already people on the lifeboats, people in the hot fusion community on the west coast of the United States who know about the eQuest device, and they're salivating because they know hot fusion is going to die. So they're going to jump ship, get in their lifeboat, and get on with cold fusion, of course. It's inevitable, all right? But our friends still up there, they prefer to go down. And, well, actually, it's not a bad idea. Have a good trip, guys. Cold fusion is the mother of all anomalies, in my view. I think there are some deep implications that will happen after cold fusion becomes the indisputable fact that it is to those who objectively look at it. But it could be business as usual. It could be, oh, we made a terrible mistake, just like we did with continental drift. We tortured the people who believed in continental drift for, half a century until it was proved beyond question that the continents were drifting. All right, it happened again. All right, this time it's very dramatic. I mean, year after year, vituperative language against cold fusion, total ignoring, total blocking, but it could still be business as usual. Will there be, as a result? Hopefully not. Widespread rejection of the establishment? I really hope in a way that doesn't happen, but the establishment actually should be taken to task, held to task for this incredible hiatus that we've had with cold fusion, the one that's going to make us all rich. That is, the people who are pursuing this. Might there be increased acceptance of other anomalies? I think so. I think this could well happen, and I hope it does, because there are lots of things out there to be investigated, and I think there will be a new metaphor that will enter the language. Cold fusion will no longer be a joke, like, oh yeah, like cold fusion, a joke. Cold fusion will be a kind of a victorious, wonderful word. And with that, I am going to end this talk